In this video, we're going to discuss slope. We use slope when we want to characterize how steep a line is. So let's look at this graph on the page. We want to find the slope between any 2 points, this green point and this purple point. How are we going to do that? What slope is, it's the change in the y values over the change in the x values. So what slope is, it's the vertical change in the graph depending on the horizontal change in the graph. So let's look at what the horizontal change between the green point and the purple point is. We always want to move from left to right. So we're going to go down here, we could draw a little line. That's our horizontal change between the green point and the purple point. And we see that it's 1 box. So our change in x is 1 box. Now let's look at our change in y values. From this point, from where we left off by the horizontal, we're going to move up to the purple point. 1, 2, 3. We moved up 3 boxes, so the change in the y values is 3. So the slope of this line is 3. But let's say we wanted to find the slope between 2 different points, between this red point and between this yellow point. We're going to do the same thing. We're going to first measure the change in x values, and then we're going to put over that the change in the y values. So the change in the x values, we want to measure how far it is from that red point moving to the right till we'll be directly under the yellow point. So that's 1, 2. Our change in x values is 2. Now our change in y values, we're going to move from where we left off and we'll move up to the yellow point. 1, 2, 3, 4, 5, 6. So our change in y values is 6. If we reduce this, 6 over 2 is 3. So we know that this whole line has a slope of 3. And that's what we assumed because lines, they always have the same slope. They go on forever. They always have the same slope over the entire line. Now let's look at notation for this. Change in y can be written as delta y over delta x. This means the exact same thing as change in y over the change in x. And we can, even if we didn't have a graph, we would be able to see what the slope of a line is or what the slope of 2 points are. Let's say we take 2 points from, we'll use this line. Let's take the yellow point, which is 0, 0. And we'll take the red point, which is -2, -6. And let's see, without looking at the graph, let's see if we could get the same thing as the slope of a slope being 3. So first we're going to look at our change in y values. So we're looking at delta y over delta x. We want to look at our change in y values. Let's take our first y value, which is 0, and subtract from it our second y value, which is -6. That's going to give us our change in y values. Then we're going to take our first x value, which is 0, and subtract from it our other x value, which is -2. And let's see what we get. 0 minus -6 is 0 plus 6, which is just 6. 0 minus -2 is 0 plus 2, which is 2. 6 over 2 is 3, and the slope of this line, we use these 2 points, without looking at the graph, we use these 2 points to tell us what the slope of the line is. Now let's say we had done it differently. Let's say we did change in y over the change in x for the same 2 points, but instead of using the yellow point minus the red point, we're going to use the red point minus the yellow point to find our change in y values and our change in x values. So we're going to do, for change in y values, we're going to do -6 minus 0. And for our change in x values, we're going to do -2 minus 0. So our change in y values, -6 minus 0 is -6. -2 minus 0 is -2. -6 over -2 is +3. We got the same slope regardless of how we did it. But what you have to be careful of is that your first y value and your first x value are the same point, and your second y value and your second x value are the same point. Your first y value and your first x value are the same point. Your second y value and your second x value are the same point. What you can't do would be the y value from the first point minus the y value from the second point, and then do the x value of the second point minus the x value of the first point. These two are not the same point. These two are not the same point. Let's look at another example. Let's find the slope of this line. We're going to pick two arbitrary points on the line. It doesn't matter which ones they are. Let's pick this red point and this yellow point. It doesn't matter which points we pick. And we're going to do delta y over delta x, which is the change in the y values over the change in the x values. Let's first look at the change in our x values. We always want to move from left to right. So let's start with the red point, and let's move as far to the right as we can until we're directly over the yellow point. 1, 2. We move 2 boxes to the right, so our change in x values is going to be 2. And now let's go to our yellow point. We're going down 1, 2, 3, 4. So our change in y values is -4 because we went down 4. And let's reduce this. Our slope, the change in y values over the change in x values, is -4 over +2, which is -2. This line has a negative slope. Let's look at another example. Let's say we want to find the slope between 2 points, between 2 coordinates that aren't on this graph. Say we have the point 0, 6 and the point 4, -3. And we want to find the slope between these 2 points. So we're going to do delta y over delta x, or the change in y over the change in x. Now it doesn't matter which is our first y and which is our first x, but the first y and the first x have to be the same point, and the second y and the second x have to be the same point. So we're going to use 0, 6 as our first point. So we're going to do 6 minus, our second y is -3. Our first x is 0, and our second x is +4. Let's simplify this. 6 minus -3 is 6 plus 3, which is 9. And 0 minus 4 is -4. So our slope is -9 over 4, or 9 over -4. It's the same thing. This line has a negative slope. Let's graph these 2 coordinates and see if when we graph it, we would get the same thing. We'll graph it on the graph above with the other graph. So our first point is 0, 6. And our other point is 4, -3. Let's connect these two. And let's find the slope. For our horizontal distance, we always want to move from right to left. So we're going to start from the point at the top and move as far to the right as we can until we're directly over the point on the bottom. So that would be 1, 2, 3, 4. So we moved over 4 units to the right. Then we're going to move down to connect to our other point. We're going to move down 1, 2, 3, 4, 5, 6, 7, 8, 9. Move down 9, so our change in y values is -9. And that is the same thing as we got before when we used the points. -9 over 4 or 9 over -4 are the same thing. Let's look at one last example when we have a table of values and we want to find the slope over a certain interval. In this question, we need to find the slope over the interval x is equal to 2 until x is equal to 4. So that would be the point 2, -4 and the point 4, -8. All these are our 2 points from the table. Let's write out our 2 points. Our 2 points are 2, -4 and 4, -8. And we want to find the slope between them. Whenever we're finding slope, we're finding the change in the y values over the change in the x values. Change in y over the change in x. To do that, we're going to subtract y1 minus y2, and on the denominator we're going to have x1 minus x2. So our first y value is negative 4. We're doing negative 4 minus our other y value, which is negative 8. And for the denominator, the change in x values, we have 2 minus our other x value, which is positive 4. And let's simplify this. Minus 4 minus negative 8 is minus 4 plus 8, which is positive 4. So in the numerator we have positive 4. 2 minus negative 4 is negative 2. So this simplifies. 4 divided by negative 2 is negative 2. The slope of this line is negative 2. And we can graph it to see if that's correct. Which we won't do now because we already did practice with graphing, but you can try it and you'll see that over this whole table, since it's a linear function, the slope of this line will be negative 2. So just in summary, whenever you're asked to find the slope or the rate of change, the slope and the rate of change are the same thing. You'll want to find the change in the y values over the change in x values. If you have a graph, you can just count boxes. If you have a table or 2 points, you're going to want to subtract the y values and subtract the x values. And one last thing, whenever you have a line in slope-intercept form, in the form y is equal to mx plus b, your variables are y and x. M is your slope. And b is your y-intercept. We'll discuss that at a different time. Whenever you have a line, a y equals line, you have mx plus b, your slope is going to be m. So for example, if we had the line y is equal to 2x plus 3, the slope of this line would be 2. Say we had a line y is equal to negative 2 over 3x. It's really plus 0, so the y-intercept would be 0. But the slope would be negative 2 over 3.